1.5 minutes early. So my name is Ian Dees. I am talking today about a project called OpenAddresses. And the point of the project is to collect every single open address data point in the entire world and make it available for free as a big CSV to download. You can see Twitter there and our website. If you guys have questions, feel free to contact me. I have to be able to advance slides, though. There we go. All right, so just to level the playing field a little bit, the problem we're trying to solve, is that addresses are a basic necessity. They're a really human way of locating yourself on a map. And normal human beings, those of us who are outside of this room, they can't locate themselves without an address or some kind of reference point to find themselves on the Slippy map that we all build. And so geocoders, I'm sure we all know, but just making sure, geocoders take that human language interpretation of location and convert it into a point that could be displayed on a map that we make. The problem with geocoders is that they're really hard to write, and they're really hard to write well. I like to put this little bit on here that Google is the only decent geocoder. And the reason I say that is because they have tons and tons of feedback from users about how their results are presented and if they're any good or not. And so they take that information and they feed it back and they try to improve their application. They also have tons and tons of data that they're pulling from. They have an index of the entire internet. There's lots of addresses on the internet. They also have hundreds of people that go out and collect the data. And so OpenAddresses is trying to help a little bit there by collecting the data and making it available for people like Mapzen, Mapbox, and OpenStreetMap to use and improve their geocoders. We're also trying to, as we're building OpenAddresses, we're discovering that it's a really great way of convincing people that open data is useful and that they should think about opening their data. For example, there is a national address database project happening in the U.S. And at the summit for that, when it was getting kicked off, we were talking about how to implement that. And one of the key things that came out of there was that it needs to be open, not just because it's government, but also because it's the right thing to do. And then this is kind of pie in the sky at the moment, and I'll talk about it a little bit later, but a goal for OpenAddresses would be to serve as kind of a conduit for that feedback loop that I was talking about that Google has. But basically, if somebody who is using OpenAddress output presents it to a user and the user says that this is wrong, we can accept that feedback and then point it to the right spot. So if New York City gave us data that is wrong, we can tell them that a user somewhere considers it to be wrong, and they can do some action based on that. So some existing projects. OpenStreetMap obviously is one of the main reasons for this project to exist in the first place. It has a huge data set, but the problem with addresses in OpenStreetMap is that they're really kind of an invisible set of data. You have to zoom in to zoom 19 or whatever before you even see the points on the map. And it's not an obvious thing and kind of a tedious thing to map for people who are on the ground. And also you can't really do it from satellite imagery. And so it's kind of, there's only, after several years and 30,000 people doing it every month, there's still only 61 million addresses in OSM, and most of those are imported. There's also an existing project called OpenAddresses.org, and they were working on a project very similar to how OpenAddresses.io, the project we're talking about. But they kind of trailed off a little bit. I think it was somebody's PhD thesis project, and it kind of stopped after a while. They were also just focused on Europe. There's a project that also kind of died down a little bit, OpenAddresses UK. They were just taking people, they were asking people to enter their address to build up a database of street addresses, basically. They were not asking to put the addresses on a map, so they weren't collecting geodata. That has also gone quiet. There's also, I forgot to add this slide, but there's also the National Address Database that the DOT is putting together, and they're working really hard on that, and I'm hoping to see more information coming out about that. There's been a lot of interviews and talk about it on, and Michael is here to answer questions about that. So our project, OpenAddresses.io, it started off as a Google spreadsheet of possible data sources that I would import into OpenStreetMap at some point in the future. I had just imported like Chicago or something, and that got a lot of people ticked off by how much data I dumped into OSM. And so OSM kind of built up a structure of how they'd prefer to see imports happen in the future. And so they asked for a review and a lot of really sensible things, but multiplying that across the hundreds of sources that I was finding meant that I didn't have the time to do it. So I just built this spreadsheet, and then eventually somebody said, let's put this in Github, and that's kind of where it flourished from there. So since then, it's become a GitHub project of 1,400 or so source files is what we call them. They're basically JSON blobs that contain a pointer to the data and then some information about how to convert that data into our format, basically. There's also some software to do that downloading and converting and do some checks to make sure that the JSON is valid and the columns are correctly named and all that kind of stuff. So once we do that conversion, the output is a CSV file containing the 250 million rows that we've collected from all the distinct sources. And right now it contains a latitude column, a longitude column, the house number and unit number, a street, a city, a state, and a postal code. And that's all that it has. If you want to do outputs in other formats, you can take that CSV and translate it into whatever format you want. Or you could try and convince us to add another output. Or you could run this yourself and output your own format. This is all built very quickly. In the last year or so, we've basically doubled the number of points that we had. And we've also increased the number of contributors that have added those points. So starting off from the first map that we collected, this is basically the output of the spreadsheet that we started with back in 2014. You can see that there's a lot of counties, there's some states that are covered, but there is a lot of gray space there. And in 6 months or so, we added a whole bunch more. And then yesterday, we were at this. Well, okay, that's not yesterday. That's last week. But so this is just the U.S. also. We do cover the entire world. And I just didn't include this one initially because it's a lot harder to see the impact of more changes. So a lot of times people will ask questions about this map. The colors here indicate whether or not the data was successfully downloaded and cached on our side. The greens basically mean that it worked and everything was great. The reds and oranges mean that it didn't work for whatever reason. And so we have a a website that goes and tells us what was wrong. Each of these sources has a separate log file that we read and understand what was going on. Most of the time, it's just that the server was down at that exact moment that we were talking to it. Sometimes the server has changed URLs. Sometimes the column names have changed, that kind of stuff. And so a lot of our work is going back in and updating that to updating our sources to match the changes that happened in the source data. I do want to point out that Australia is covered now. They dumped a bunch of their data, all their data, a couple months ago, and we added that in an evening, and I think we increased our point count by a couple million at least. So one of the interesting things about this project is that it's based on GitHub, basically. The entire project is in GitHub. All communication happens with GitHub pull requests and issues. Any contribution that's made is done through a pull request because all of our consistency and status checks are done as a result of continuous integration plugins that happen with GitHub. It also allows us to have conversation and, more importantly, reward people for contributing data. One of my favorite things that happens with a pull request in OpenAddresses is that somebody will come along and post a URL, and they'll figure out the format for the source file. They'll make a pull request, and 10 minutes later, one of the maintainers, it's usually me or Mike McGursky or somebody like that, will come along and take a screenshot of the resulting data in QGIS and show that as, thanks for this data, here it is actually ready to go. And that's a really rewarding feedback loop for the people who are contributing this data because they see the output with like the same day, within the hour, basically. And I wanted to point out that, let's see if this link works. So here's a good example of a pull request. Actually, this is just an issue, but it points to a pull request down below. Somebody pointed out that Arkansas's data is available. So we went through and we had a conversation about where to find it and how to include it in our data set. And then the Arkansas GIS folks showed up and said, actually, try using this. And they helped us figure out which columns lined up with which of the OpenAddresses columns and how that all made sense. And they did some work to zip up a shapefile for us, and it all just showed up in a pull request and was merged, and we suddenly got the state of Arkansas. So that's a really great example of what can happen with this workflow. Oh, my slide fell off the end there. I don't even know what I said. Oh, I remember. I encourage everybody to explore this for their own open data projects. There's a lot of open data already out there, and I encourage you guys to steal this idea and use it for other themes of data. So, for example, MapZen just released a open terrain data set, and a lot of the data sources that I am finding as we're poking around for address data, they also have elevation data just sitting there next to the address data. And so the elevation data could also be collated and collected in the same sort of way. So steal it for your data, too. So I thought I would go through real quick what it looks like to add a source. This is kind of interesting because last time I tried to do a demo like this, somebody had already entered the source by the time I got to it, and so the demo was really boring because somebody had already created the file. So for example, here I was looking for, oh, come on. Dang it. This worked this morning. Okay, so here's an Esri endpoint, Esri layer for a county whose name I forgot because I did this last night. And it has address data, address point data. Here's some fields some column names that we can put into our source file. Please work. Oh, that's sad. So anyway, the point here is that we would take this Esri layer. We would take the field names out of this source layer. We might look at some examples. We would create a new source file in GitHub, create a pull request that talks about what county it is or like where the data came from, some links to the website where we found it, and then make a pull request, and we would all wait for the caching and conversion and checking steps, and then merge that pull request, and it would end up in our data set. That's what I get for trying to demo. All right. All of this stuff happens on a EC2 instance. It's a simple Python backend that does the work of downloading from Esri or FTP or HTTP, expanding or decompressing a zip file. It converts the geodata in whatever format it is, shapefile, Esri, GeoJSON, into a CSV. And then that CSV, the columns are plucked out of it in the right order and renamed to match our output schema. And then there's another process that runs once a week or so that collates all those CSV files into one big zip, and that's what gets posted on our website. And you can download that and build your geocoder off of it. So a lot of the time I get questions about what kind of schema can I convert this schema to some other XML format or something like that. And the philosophy there for us is that we're generating the CSV based on what our consumers' needs are for now. We're also saving the cached data from the source at every step along the way. And if we need to add or change the format in the future, we can really easily go back and run the exact same thing with this new output format and get the new output format using all the exact same data. If we need to change anything, for example, we recently added the unit field, we can really quickly go in and add that as an option in the output format. And we just pick CSV because it compresses nicely and it works really nicely with point data. We also generate VRT files so that you can open this all up in QGIS without doing any other conversion. Another question that comes up a lot is licensing. We don't assume any, we don't change any of the licensing. We keep track of what the licensing requirements as we understand them are from the source. So in some cases, there will be an attribution requirement, and we'll list attribution equals true, and we'll say what the attribution needs to be. In some cases, very few cases, there's a share-alike requirement. We'll set that to true, and we'll talk about what is required there. In the vast majority of cases, the sources don't consider this to be copyrightable, because it's facts and it's just out there. It's non-copyrightable data. Our output format, our output files do group share-alike into its own zip file, basically because it is it allows the consumer to do different things with it and consider it a different source name. For example, see if this works. MapZen uses OpenAddresses for its Peleus/search project as one of its data sources. Peleus allows you to import several different data sources, one of which is OpenAddresses. So let's search for this building's address. And you can see in the output from Peleus that it is a OpenAddresses source. So they merged the OpenAddresses data from OpenAddresses, which we sourced from the county here, and actually from the state, I think. And, oh, nope, from Wake County. It says right there, right above. And they merged that with their other data sources and use that for their search product. So where can we go next? I think that that crowdsourcing points, as OpenStreetMap is doing, isn't really sustainable because of the things I mentioned before, but also because there's a lot of walking we would have to do if we had to do that. And also, there's governments that are already doing that and also creating the data because they're the ones issuing the addresses. So we should find those entities and talk to them and ask them to give us the data that they're creating, that the citizens are paying for. So to that end, I think we're scraping the bottom of the bucket in terms of obviously open data. So things where when you do a search for Esri address point in Google, all of those sources we've already found and added. The excellent open data ArcGIS site, we've found all the open data address points there. So now we have to go talk to people, and the engineers that run this project aren't very good at that. So we basically need to build a sales team to go convince people to give us their data and do that systematically. I haven't figured out how to do that yet. If you or anyone you know knows how to do that, let me know. And hop on GitHub and talk to us. Sorry. There's also a lot to do internationally. So a lot of what I've been talking about today has been related to the US, just because that's where it feels like we're making the most progress, because we're filling in the most boxes. But there's a lot of other places in the world that have address data and have it electronically, and we could find and try and pry it out of their hands. We've done that in a lot of places where it's obvious, but there's still a lot of places that don't release that kind of data. We should try and figure out why and be a part of that conversation. And I kind of mentioned this before, but one of the things that would promote release of open data is by having a feedback mechanism, so that if New York, like I said, if there's a county that has data and is questioning why they would release it, we could convince them or use it as a positive thing to tell them that they'll get information back about where their data needs improvement or where they could spend time improving their data. We could also do a better job of talking about licensing. I kind of touched on the stuff that we're doing now, but I think there's a lot of questions about if we could improve that and if we could help users of this data be more certain about the licensing behind it. I think that might help some people take it up and use it more. I'm sorry, you guys haven't seen any of these slides. You guys should have yelled at me. I'm sorry about that, guys. One thing that you could do is, if you live in a place that has open data, or if you are a creator of open data, you could let us know. Maybe we don't have your data, or maybe we're pointing in the wrong spot. It would be super helpful to hear more about why you're releasing open data or why you're not. That would be a really interesting conversation to have, and I would be really happy to do that. I also want to thank AWS and Code for America. They're the ones that are running the hardware, basically. And also, Waldo Jackwith's US Open Data ran a really interesting bounty program last year where they basically paid a certain amount of money for each source that was added, and that really helped improve the data and made people more aware of this project. So here's my contact information one more time. Feel free to ask me any questions later or now. Yeah. Yeah. Is that Canadian or Australian dollars? Sorry. Yeah. So the point there was, if you spend a lot of money, open data can happen, as in Australia. Yeah.
What features are you assigning addresses to?
That's a really good question. So, yep. So the question was, what features are you assigning addresses to? And we are not assigning any addresses. So we're just gathering. We have a field in our source that tries to describe where the source describes their point. So in some cases, it's a centroid of a parcel. In some cases, it's a driveway. In some cases, it's a building footprint centroid. We try to, basically it's a number right now that categorizes where the source says their feature is, basically.
But some organizations address car ports, they address cable boxes, they have all that good stuff.
Yep.
Are you only looking for structured addresses?
We're looking for all addresses, any address point.
Cable boxes?
Yeah.
Signs?
Yeah. I mean, we haven't found any of those kind of address points, and so we haven't run into that problem. But so the vast majority are of sources that we already have are from local governments who are addressing buildings, parcels, or driveways. And it would be interesting to try to solve that problem. That's one of the things we talked about at the National Address Database Summit thing. Yeah? So the question is, how do you handle non-American address types, non-city?
There are some addresses in the U.S. that would be
Right. Yeah, that's a good point. So we don't handle that very well right now. It's basically, if it doesn't fit into our output schema, we try to bend it to fit into our output schema. We haven't. One of the side effects of doing the build process the way that we do is that we don't spend a whole lot of time poking through every address that we see. We are usually reacting to our consumers' complaints about the data format. And so, for example, sometimes the Peleus engineers will come to us and say, the addresses in the entire state of Wyoming have 0 for their house number. And so we have to go back and fix that. We have not come up with a case where we've run into addresses for PO boxes or for descriptive addresses or something like that. And so we haven't tried to solve that problem yet. It would be fun to try and solve it, though. Yeah?
Sort of the data sources are hard to see, right? Just bringing in point sources, or are you also bringing in Polygon, like building your parcels?
So the question is, what kind of features are we bringing in? What are they, polygons or points? We are bringing in all sorts of features. So we're bringing in parcels and points, for examples, or building footprints. And we take the centroid of a polygon when it's a polygon.
Do you have a sense from that, from all the sources out there, which ones
So I think so we have a kind of a side project happening where people are interested in parcels as an output of this, and I think we discovered that roughly 30% of our sources, maybe 40, are actually parcel polygons, and so that's one of the reasons why we're edging towards building a parcel fabric data set off of this, because a lot of our data is already parcels, and we could just output the same data. So that's roughly, I'd say, the vast majority of points, though. Yeah. So there's a group of people that hang out on a Slack channel. There is maybe 10 people who are really into and core contributors to the code and to the decisions that are made. We're trying to improve that situation by getting ourselves situated under some nonprofit and building a governance model and trying to defray liability problems and set up legal structure and all that kind of stuff. So we don't have one yet. Right now, the domain is registered under my name, and we're trying to make that better. Yeah, that's a really good point. So the gentleman was talking about a lot of different data already exists on addresses, and it would be really great to have some organization that linked them all together in a way that didn't make that organization wasn't trying to make money, and so it was trying to raise everybody's boat, so to speak. Yeah, definitely, and yeah, and I think I hope that that's what the National Address Database does. I hope that the National Address Database creates some kind of system for that in the U.S. Maybe we can be that in the future for the international community. Yeah. Yeah, that's a really good point. So coming up with a private-public community partnership would be a really interesting way to add to the data set. I think what it would take is somebody like Bloomberg, for example, releasing data with their internal ID and then the public part of whatever data they want to share. And based on that, we could do a lot of interesting things with matching and all that kind of stuff. We'd be happy to be that repository for information. Yeah. That's a really good question. So the question is, what percentage of U.S. addresses do we have? And there was one graph that I was looking for that I could not find. But one of our contributors had built a graph of population to address points in our data set, and it was roughly linear, 2 address points, or 2 people to every 1 address point. And based on that calculation, I think we had something like 60% coverage. I mean, that was a pretty non-rigorous test, but there's definitely a lot of places that we're not covering. So everybody can go to lunch now. Thank you very much, everybody.